This webinar is brought to you by Live Lab Learning, which is a subsidiary of Academic Corporation, a wholly owned applied software company, created to provide world-class training. This is Marcia Tucker, and I'm delighted to be your moderator today. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the Windows questions pane. We are answering your questions at the end of the presentation. And wanted to make note of our upcoming events. We have HSM Works, Southern Automotive Conference, and First Coast Manufacturers Association Summit. If you'll make note of those, I would like for you to also know that Dennis is an accomplished, qualified veteran and battle-scarred professional with more than 25 years of experience in project management, technical account management, and CAD management, along with Autodesk software leadership. He has more than 10 years experience in implementing CAD in various industries with an emphasis in machine shop production. He has developed and advanced programs to allow CAD designs to integrate with automated CNC machinery. He's been with Applied for 24 years and has conducted classes for thousands of engineers. His students love him and rate his instruction among the best they've ever received. His education includes Mercer University, Georgia Tech, and of course numerous Autodesk professional training. So please join me in welcoming today's speaker, Dennis Howell.
All right, thank you, Marcia. Let me see, I'm going to drop this PowerPoint back down now and welcome everybody that has shown up. Now, what we're going to be covering today is the Autodesk Design Suites for workflows for digital prototyping, and we're going to be focusing on a handful of the products, not every single product that's in the suite, but the primary products. And I thought I'd start first off with Showcase. This is a product that's for taking models that you might develop over inside of Inventor, Autocad, etc. And so as an example, to show you the different types of files that this will open up, you'll see it goes right down the list of all the Autodesk products, as well as a few of those that we won't necessarily mention that are competitive products to Autodesk. But again, it can open them all up into an, as you can see here, a already rendered environment. It is purpose designed to work that way, so it's constantly going to be inside of that type of environment as you're working through it. Now, what it's nice for is to be able to quickly change the way a model or an assembly that you might have put together in the render environment so that you can fully interact with this and see it in the real world before you actually make the first part or fabricate the first part. And so as an example, if I can select here on different parts, right-click, and then do add all of those particular components that are made of the same material to a list, and then I can add that as an alternative to my list of materials applied to that particular objects that I've selected there. Now I'm going to bring up my material library. This is pretty much the standard material library that comes out of most all of Autodesk products. And so again, it's a pretty extensive library of materials that you can choose from. And I'm just toggling here to show you some of the different options that you might have. Now, with a certain part selected, I can always go back and say, all right, let me see what that might look like in as an orange material or orange color. And it updates it, and I can save that now as one of my material lineups over here into my appearance interface. And so now if you could look real closely with the icons over here to the right, you'll see that I've got a yellow one as well as an orange one. We'll add one more, a nice olive green, and then we'll add that as an alternative as well. And so you can very quickly change the way your assembly or your components look on the fly directly inside of this product. As you can see, it has the standard capabilities of being able to rotate the model around, look at it from different angles, as well as adjust lighting and shadows. And another option that you have with it is to be able to change the backgrounds. And so here once again we can switch to different materials as we were looking, as well through the interface down at the lower side here. I can switch and bring up a library of different backgrounds that we can place our model into. And so as one example here, I'll bring you to kind of a building environment, where we can see now our model. Now I'm going to close this back down so that it's not quite so busy looking up on the screen, and as you can see now we can begin to see our models directly inside of an environment now, so that again we can see how they're going to look in the real world prior to anything actually being manufactured. And in this real world I can change the different colors and see how they look in that world as well. And so various capabilities that we've got here with this particular product called Showcase. One of our other options is to work with the lighting. And this is actually kind of almost, I like to refer to it as fun, is where you can actually pick and drag on shadows. Not something that you could do obviously in the real world, but if I wanted to highlight an area, I'm actually changing the light source by grabbing the shadow and moving it over to the side a little bit to give my look a little bit more bright, a little bit better, and so that I can see it better, and then taking it right on over and being able to compare now my different materials to see how it's going to be looking as I change the materials and how it interacts with the environment that it may be going into. So that is the Showcase. It is one of the products that's in the two suites of the digital prototyping, what's referred to as the digital prototyping environments, which is your factory design suite. And in this case, the product design suite is what we're going to be highlighting today. Now, these models can be taken out then, used in, from Showcase, used in materials for marketing, as well as informational product information sheets, spec sheets, things like that. So again, that the users or your customers would be able to fully see exactly what the product is going to look like with its different sizes, different, in this case, being a front loader bucket. We can see the different capacities of the bucket, and so again all of that can be brought right into the materials for marketing as well as in specification sheets. Now we're going to jump over into Inventor now, so I'm going to close a few things down. I always have to do this so that I can keep my system resources up. And so now you can see the fully assembled model here within Inventor. And Inventor is the suite for, or the product within the two suites that is primarily used for building componentry and then assembling that componentry into a model of whatever the product is that you might be working with. Now there's various capabilities. I'm going to show you some of those capabilities as I work through the product here as far as how the Inventor works and develops its models and all. And one of the primary areas that is being developed more and more within Inventor is the iLogic capability. And I'll bring the box out here, dialog box out here a little bit more so we can focus in on it. And you'll see that there's various, a section here for various rules that can be written. And if you have any familiarity with VB scripting, it's very much a VB script environment. So if you're familiar with that environment, of course, you'll be able to jump right in there and start doing some of this iLogic capabilities as well. Now I'm going to drag it and put it back into my panel over here to the left, and we're going to go to what they refer to as the forms area, and you can see these can be set up and customized for all different types of layouts to make it quick and easy to toggle between different setups for your components within the model, individual components as well that might end up affecting the entire assembly as well. So in this case we'll see that our default setting here is a small loader. We've got two other tabs for medium and then large loaders. And then we've got some bucket capacity as well as tire styles that we can toggle through here. So the environment has gone through quite a bit here to get it into an area where it can be fully utilized within the iLogic to change the overall shape and size. In this case, I'm going to be demonstrating the bucket changes. Depending on the customer needs, specifications, loads that it's going to need to carry, capacities, etc. So as an example, right now it's more or less in the small section or small load. And so let me zoom in here a little bit on it. And so if we take it into a medium capacity and go into a little bit larger load, you'll see that it takes it a moment to update, and so it's going through its thing here. Hang on a second, I think I need to reactivate the entire model here. Let's go that way. All right. There we go. Now it's going through its update. And you'll be able to see visually up on the screen now the loader or the shovel area here has actually gotten, the bucket size has gotten bigger now. So again, we can toggle through those different sizes. Now I'm going to rotate the model around. If we look on the underside, you can see the stiffening supports that are along the bottom. And so once again, that's in more of a light duty. It's only got a couple of them being represented there. Now, one other area that I do want to emphasize here, though, is I'm going to jump back over and bring open another model, or actually a drawing of this bucket. So let me go in here and open that drawing file. Now that's again part of the workflow between specifically within Inventor is being able to not only model these items as you build them, but also document them. And the documentation capability again is directly off of the model. So as you toggle back and forth, if you're familiar with AutoCAD, it's very much like being in the layout environment of AutoCAD, where you can have different sheets. I'll just toggle between the two, and you can see the two different sheets here, very similar to an AutoCAD environment with that. But if we take a quick look, as I showed you over here over in the assembly when we extended this out and got our bucket a little bit bigger, we have the two supports, strengthening supports here, and we come back over here. Of course, here's our documentation of it, and it is called out in our parts list as 6.18. And so if we go over to our sheet 2, which has our parts list, you can see 618 showing us that we've got the two stiffening supports there. Now, if we come back to our model at this point, one of the other options within the iLogic is to be able to even change other parameters, not just the size, but we in this case could even have it set up to take it from being light duty, which is represented by the two supports, and take it into heavy duty. And so by clicking on that now, you'll see that the 3D model will update here shortly once it gets through going through its settings. And we'll actually have 3 stiffeners on the bottom support to handle the heavier load. And so now you can see there's our 3 stiffeners. And if we go now over to our drawing file will also update. So here at this point now, our 618 has updated in our parts list 3. And let me move this box out of the way so you can see it a little bit. Anytime you see a little red lightning bolt there that says, hey, I've made some changes and need to be updated. And so if we double click on that particular sheet now so that it's activated, we'll see now that we've got the 3 stiffeners and supports have been added into our documentation. So all along the while, as you're modeling and developing your models and then you make changes, the documentation side of Inventor will keep up with you as you go. So that, again, at all times, your documentation for fabrication will be up to date along with the model as the model changes. Now, let's take a little bit deeper look now at the shovel assembly area. And so what I'm going to do here again is just drop out of a few things. Again, saving system resources here, so I'm going to drop all the way out of this particular assembly. And I will highlight here a little bit of the differences now in the 2014 versus the anybody that had the early versions in the way the layout's a little bit different now inside of Inventor. You actually have kind of your history of files down here at the bottom that you can move through. And then you can go and find, of course, then any existing or previous models that you were working on. You'll be able to have nice little pictures of them. You'll just be able to click right on them, go right into them then at this point. And so now we've isolated down a little bit here to the shovel chassis assembly area. And as with anybody that's familiar with Inventor, you can have and work with movements. Okay, whoops, let me get back out. I didn't mean to double click. So that you can work with the movement and work out how the assembly is going to work with in relationship with itself. And so your constraints can be defined. You can actually go in there and define driving dimensions versus or driving constraints versus other constraints that would just be fixed or following constraints. And so with that, you can begin to work out and see how your components and models are going to work with one another. The other aspect of this, of course, that's working within the environment of the solid models, the various components and being modeled and all. But you can also work oftentimes, if it makes sense, you can work with more wireframe style, sketch styles, where you can go in there as well. Let me kind of isolate this out a little bit too, and actually work out movements in a simpler form so that you can be able to, again, before you even start modeling the 3D components, be able to get a good idea of the shapes and the movements that you're going to need ahead of time, even before you start getting the components, individual components modeled. Now, part of the workflow that goes along with Inventor in the digital prototyping environment is, of course, the utilization of multiple different products and tying them all together. So what I'm going to show you here is a little bit of integrating Autocad, standard old Autocad, using your legacy data that may have been originally designed in Autocad to maybe redo the shovel portion here of our model. Now, as I double click on a certain area, okay, that isolates that particular area out, and so this whole area now is kind of isolated, and you'll notice that the modeling part has kind of gone into a let's say a kind of a see-through transparency look. But I can also right click on it and then go in here and do other other steps on it as well. I can come over here into the model and right-click on it in the browser area and say open it. Now I'm going to do it that way just to isolate out just the shovel area so that we can see it a little bit better and not have the overhead graphically up on the screen. I'm going to keep the original model open over here, but again you can see kind of the tabbing sequence that we're used to with Windows environments, where this will be now laid out over here to the individually, and that we can work on it separately now at this point. Now, one thing about Inventor is it's easy to develop work planes, and so you can see I've got a work plane here created already down here at the kind of on the underside of the shovel. Of course, we can right-click and turn that visibility on and keep it on if we so choose, or you can turn them right back off. It's all, again, personal preferences there. Much of the heads-up display is now available, where you've got the icons right here on the screen that you can work with, again trying to keep the user interface simple and with regard to a lot of the interfacing now. Although those of you that like dialog boxes, they are still available and still show up there as well. Now, in this case, what we're going to do is utilize some legacy data from AutoCAD. So I'm going to start a 2D sketch where I can either come over here and say create a 2D sketch with the right here in the center of the screen with my heads-up display. With that work plane selected, I can also come up into my ribbon interface and say start a 2D sketch as well. So again, personal preference there on which way you might want to work with this. Now, my orientation and all with the sketching, I'm not certain I like it sometimes, especially if you're familiar with working with AutoCAD versus Inventor. Inventor, its y-axis is generally thought of as up, while with AutoCAD the z-axis is up, and so sometimes that can cause some ways that the AutoCAD information comes in. It can kind of come in oddly. But here in this point, what I think I'll do now is just create a 2D sketch real quick, and then I'm going to edit that 2D sketch by changing its coordinate system just a little bit. And with the capabilities now within the environment, I can actually select on different axes of Inventor now in the environment that we're working in, select on it, and say, well, I want to orient that axis, for instance, with my x-axis. And so you see it's flipped it back around here to kind of more oriented with the x-axis of our overall origin versus maybe what was specific to that point at the time. Now, I can come right back now, right-click, say OK. I can come back now to my sketch, double-clicking on it. And again, now it's looking a little bit better in the way that it's coming into to my setup. I'm going to project a point, that little point right there, just to have a nice snap point to go to. And now I'm going to go out and find an AutoCAD drawing that I might want to work with. Now I'm going to drop back here. I've got a couple of drawings loaded here already. If you'll click here on the top view of my bucket, I'll say open. Now, utilizing some, again, some integration of other products that come with the suite, it is utilizing the TrueView product here at this point to actually show me the model that's inside of AutoCAD. Of course, I can toggle between a model space view versus a paper space view, and I can pan it around. I can zoom in and out. Right now, I've got it set up to select everything. You'll notice it's based on layers, just like we would normally see in AutoCAD. Of course, I can turn certain layers on and off. You'll notice, too, if you're familiar with AutoCAD Mechanical, that this is an AutoCAD Mechanical drawing, which does come into in with the Product Design Suite. So you do still have that capability and the intelligence that you've put into AutoCAD Mechanical if you've been using that over the years. Now with this, like I said, I could turn off the all selection and actually select on as a window up on the screen, but in this case I want the entire model or entire sketch that's been laid out there. I'll go to my next button, just making sure I've got a few settings here that I want it to come in as. For instance, I want my endpoints to all be constrained with a coincident constraint to bring those in and to detect the units and all for me, and I'll say finished here. And it brings it in. Now at this point, to show you the integration between AutoCAD when you bring these models in or these layouts in into Inventor, I'm going to turn on the display of the dimensions to expression mode, and you'll notice that it is recognized as in Inventor as dimensions, and so it does give them a numerical value as well as a name value. So again, it isn't just bringing it in as if it was lines and arcs. It is bringing in the actual values there. And of course, then all of our geometry then is tied down based on these dimensions. Now I'm going to do a quick move here. I want to move this profile into place. So I'm going to window it real quickly, like so. Do my base point. I've got a nice little point right there that I'm going to grab. And I'm going to move this to that point that I projected right up here so that I can get that, that profile position now and into place. I'll say done at this point, and I'm done with the sketch, so I'll say finish sketch now. Now at this point, that is the top view of our legacy shovel design that we want to make use of. And here is again the capability showing you how the Autocad is integrated directly right in with the Inventor when you bring these models in or these layouts in. What I'm going to do is do an extrusion of the inside of the shovel, let's say. And so I'm going to pick that, and as my value over here, if I knew the value, of course I could type it in. I can look down here and see the value. But again, the integration that we have here is to be able to just select on that particular dimension right there. Okay. Okay, I'm going to change a couple of settings here. I'm going to change that to be a symmetrical, get my dimensional value up there and pick on it. And so now we can see it has stretched it out or extruded it out in a symmetrical fashion right across our screen there. Now, in this case, I'm using my heads-up display as I'm working through this. I've noticed that if you keep moving your heads-up display over to a certain location on your screen, it'll eventually have all of them set to that location, which is where I prefer. If you prefer the dialog box is still there as well. So again, you can make use of either interface as you're working through this. I'll say OK to that. We can see now how it has projected our model out. I'm going to turn the original sketch back on so that we can see it. And again, going through down that same concept now, I'm going to grab this profile and using my control key, grab that second profile on the underside. Once again, going to my heads-up display, I'm going to make that symmetrical. And then once again, for my dimension, I'm going to pick this inside dimension there. So now you see it has changed this feature and dropped it down a little bit smaller, representing the section of our shovel or our bucket for the connections of our other components as we start building this assembly. I'll say finish to that now. Now, as you saw earlier, we were working with this bottom work plane to actually bring in the AutoCAD drawing into that environment. I'm going to create a couple of other work planes very quickly here based off of our XY plane. So I'm going to click on that and then tell it that I want it to come in to this point right there. And then I'm going to do the exact same step again and get my point to the outside here. So now I've developed two work planes directly above those section lines that we've got down here at the bottom for our profiles based on our legacy drawing here that we brought in from AutoCAD. Now at this point I don't have to do any extra geometry, no projecting of profiles or anything like that. Because I've got those sketches originally brought into my modeling environment here, once again I can say extrude and using my control key select those two items, but this time as far as my options I'm going to go over here and say between two faces, and so I'm going to say I want that to be developed between those two planes that I just created. And one thing I'll point out here real quickly for those that have used Inventor in the past and maybe not seen the 2015 yet, you'll see that now our work planes actually have their names put on them. So as I created work plane 2, work plane 3, it developed and put the names on the work planes as well. Makes it a little easier to figure out which work planes you're on sometimes. I'll check that box there, say okay, I've got that particular feature now put into place. As is usual, I can always come in here and turn off visibilities so I can see it and focus in on it more. And then again, I can use my pattern mirror and select my feature. And then as far as my mirror plane will be that original XY plane and mirrors it right over. And so again, I can, utilizing both AutoCAD data and native Inventor data, I've now got this model being developed where when I come back over here into my 3D world, I can begin to see how it is shaping up with the rest of the assembly. So again, using AutoCAD legacy data to be able to get in there and drag in information that I originally had in Autocad and make use of it inside of Inventor. Once again, making life easier. Why draw something twice? Just draw it one time and be done with it. So again, just go and grab that information and then continue your modeling environment within Inventor from the Autocad drawings. Now, I'm going to drop out of this. One thing I want to take a look at is my connecting piece here and see if it's going to handle, be able to handle the stress that might be involved. So let me drop out real quick here, get again, kind of reclaim some system environments. And I'm going to go and grab that particular part of the chassis. And so here we are with our connecting arm, and I want to see if it does indeed have the strength in its design to be able to to handle the loads that might be placed on it. Now, one thing about Inventor and the way it's designed, I'm going to drag my end of part down. You'll notice here as I drag that down, it cuts this particular arm in half. Now, utilizing the simulation of stress capabilities inside of Inventor, this can actually make life a little easier for setting the model up so that you can see where the stresses are, but it's just as accurate as if I had done the entire piece. But again, this simplifies the model, making it a little bit easier for me to be able to see what I'm doing and get my settings the way that I want them. So what we're going to do now is go into our Environments tab up here, and you'll see that there's various environments that you can go into with Inventor. And what we're going to be doing is working on our stress analysis. And so we're going to hit stress analysis here and then create a simulation. Now we're going to just do a static analysis here. I'm going to check our context type is going to be bonded here or welded. And at this point now I'll say yes, all those settings look pretty good. I'm just checking them here real quickly. I think we're good on those. And so I'll say OK to that. And you'll see now that our environment has changed a bit. And so now we've got various readouts that I can say show the materials and expand down. We can see the steel that's being located here. Now I'm going to check a few settings here as far as my frictionless. In other words, this area here, the face and this face and this face, representing where it would actually be connected to something else or actually itself. And so there's no friction there at that particular point. So I'm going to say OK to that one. And then our next setting that we'll want to look at is to set our pin or our rotation axis, where there's going to be that type of movement. So I'll go to my pin, and of course that's inside our rotator arm here, our elbow area. And so with that now, let's see, we can look at a couple of our options: fixed radial direction and fixed axial direction. So again, that sets the diameter line, you might say, or the rotational axis of our point. And with that, then we can say OK, and constraints are being built now. So there's our pin and there's our frictions. So we can begin to see how these are being developed, get right back to them. We could modify them and change them if we needed to. Now, as we move along, of course, other settings we're going to want to apply are the fixed settings. Okay, so we're going to do a fixed constraint now, which will be down in our side over here. And again, I always like to pick the kind of like the full cylinder look versus maybe an edge, because that will define the way the loads and the stress is applied a little bit differently. So I want to get the entire surface there for my fixed constraint. So that'll be our lock point. And then our next constraint that we'll want to put down is our force or our pressures that we're going to put into play as well. So give me a moment here. let's see, let's say OK to that. So our force, right over here, is going to be down on this one. Again, picking that. And let's see, expand the dialog box out here. You can see our different settings that we can do. So as we apply that load, I'm going to use some vector component constraints here. And on my Z directional value, I'm going to put in, oh, let's say 41,500 load. I think that will do us nicely. And at this point then say OK. So that has got our loads developed now at this point on our part. Now we can turn off some of this representation up on the screen as far as the direction of the load. And if we take a quick look now, let's see, I need to define our contacts too now that I'm thinking about it. So let me hold on a second. I wanted to, let's see, timeout. I've lost my setting here, fixed settings. One moment, please. Sometimes when I'm talking, I forget what I'm doing, and I think I've missed a step here. I'm trying to find my put my force in, display that off. Bear with me. Oh, okay. I am, there it is. There's my button right there, automatic. So with that now, I've defined the, basically you could think of it as the weld points where the section of metal as it comes into our face over here is defined as well. So as I click on it, you can see how it highlights the edges of where the weldments would be or the bonds would be with our model. Now at this point, as far as the basic setup, we've pretty much got it now at this point. I think as far as any other couple of steps that we can do, a lot of folks want to set up the meshing as well and how much element size, what the element size is going to be, and a lot of times that is something that a little tighter, smaller size might give you a little bit better values. And so then we can create our mesh view. And so now at this point, a lot of times you might look at that and just be sure that it is meshed well enough that you think that yes, that looks good. So we've got our mesh done now. Don't need to keep the mesh view on. Now at this point we can just say simulate and let it build the simulation of the stresses. All right, so we'll let it run through that process, and so now we can begin to see exactly what this is going to do as the loads are applied. Now my color is a little hard to see here, so I'm just going to put my cursor on it and let it highlight it. As you can see, it's showing the deformation. We can adjust that, maybe exaggerate it a little bit so that you can see a little bit better of where the deformation is going to be. Oftentimes I like to do the actual to really see how much deformation there's going to truly be with the loads that you've put on it. But a lot of folks like to do it a little bit there so that they can exaggerate it and see it a little bit better as to how much where the deformation is going to be on our part as the loads are applied. Now, one of our hot spots as we look around this part is right down here in this section here. And what we can do is actually probe that area by picking on it. Whoops, hang on. Probe levels. Oh, probe, here we go. I can probe that and see exactly what the stresses are, in this case 62.3. And we can, generally speaking, what we're shooting for is a safety factor of between 2 and 4 based on the material stresses and capabilities. And so at this point, I can come back over here into the way my results are presented to me and hit the safety factor mode. Okay, and it'll actually, let me double click it, it'll actually update it. You can see the graph has changed as well as the coloring of the product, is, the model has changed. And our probe has changed as well, showing that we have a safety factor of 3.32. And so generally speaking, like I say, if we can shoot and hit between 2 and 4 on the safety factor, then we feel like we've got a good part and something that will hold up to the loads as it's being generated in the model. So with that then, we've confirmed that our arm here, our lever arm, is going to be strong enough and be able to hold up for the changes in the weights and the loads that the shovel or the bucket will be having to carry with our particular design. Now, another area that the digital prototyping environment has that we can take a quick look at is the integration, again, with another product, another Autocad product, which is the Autocad Electrical product. Now, in our environment, we do now have a cable and harness environment. So first off, just to kind of change our focus a little bit here, I'm going to go to just the, kind of jump over here and show you the electrical cabinet that's involved with our shovel, our front-loading shovel. And so we can see that there is some layout here that was done. Now I'm going to drop Inventor down a little bit, pull it out over here. This is the Product Design Suite Ultimate user interface here. And you can see it lists out all the products that are available within the program. And I'm going to click on now on the Autocad Electrical. So the Autocad Electrical does come as a member of the product suite. And so with that now I've got my model brought up here. I'm going to bring up my initial wire layout drawing. And just to give you a little bit of an idea of how things work inside of Autocad Electrical, and this will be kind of showing you how we can integrate and make use of AutoCAD drawings within the 3D world. Now, generally speaking, the electrical product is a 2D product for doing diagramming. But in this case, we can jump back over into our schematic layouts, and we can, of course, lay out some wires. Standard AutoCAD environment here, it is a project-driven environment, and when I come over down to the bottom here, you'll see there's the command prompts. I can click, for instance, on wire types. Wire types, of course, are what's set up ahead of time in our environment, so what types of wires we want to use, and in this case, I'm going to use a red 10-gauge wire. I'll say OK. And one of the things that we have now is some real quick entries, keyboard entries, command line entries to being able to show us where the connections are. And so you can see I can come right over here now and I can snap right on that connection point. Now, and one of those things that makes AutoCAD Electrical so easy to use is that it understands where those connections need to be. And so you can just kind of get close to it. It gives me those little X's there representing where the connections are. And I can go ahead and place it. And it knows how to lock it in there and get it into the locations that we're wanting. So again, you'll notice I didn't have to use ortho. I didn't have to say ortho, draw to this point, and then pick another point. I just picked the two connection locations. And from there, it knew what to do as soon as I placed those points. I'll go and grab a couple of black wires now, do the same thing with my representations, And I'll come up here and pull this into that location, and notice it immediately does the pass over, the pump over. And then again, I can go right back down into my final location and bring that one up as well. And again, you see the multiple passovers that it puts in there for me, saving me a lot of drafting time there with the layout. Again, another capability, of course, is the wire numbering. So in this case, I could say, let's do all the wire numbers that are unnumbered. So a bunch of them are already numbered already. Go into sequential value, and then tell it just look through the entire drawing, and it lays in the wire numbering for me. Now, once you've got your wiring laid out, there is a import-export option here to take it out to an XML file. In this case, sorry, I'll just point to it and I'll show you that it writes it out to a location, of course, wherever you decide you want to place it. So I've got a demo area here that I'll jump into. Oops. Here and then into electrical, and it writes it out as an XML file. So with that, now again, I'm going to drop out of AutoCAD, come back into my Inventor world now. I'm going to open up my box now individually, and here once again, just pointing out what's already been done inside the model is the box layout, and of course my connection points, as well as using the environment for our tube and pipe. We've gone ahead and laid out some of the piping in there, some of our tubing in there. Okay, so now with my cable and harness environment, I'll scroll down here and just reactivate it. I can now import that data. Let me go browse, make sure I get the right one, and we'll say OK to that. Now, of course, here is our electrical parts that it is worked with and the wiring that it's brought in as well. Now, at this point, what it does is it just brings it all in. I don't need to see the log file. And it goes from the closest, like the bird flies. It goes to the, just a straight line as it runs through there and puts those wires in. Of course, now we get to go through the process now of telling it how we, which tubes we want it to actually go through. And of course, up here, that's for some of our commands up in here in our cable and harness environment. I can say route. I can pick those wires that I want to route. Okay, so I'll just grab that one right there as well. I'm going to skip this one for right now. We'll come back to it. And then the only thing left for us to do is to tell it the beginnings and the ends of the pipe segments that we want it to follow. I'll say apply, and it runs those lines in there. Now, at this point, it might have been hard to notice, but it actually may have changed the size of our tube there to accommodate the wiring. So if I run through this again and add some more wire to it, I think we'll see it a little better. So I'll grab these 6 pieces, and again, making my first segment here, and my second segment back there. And we'll say apply. And you'll notice now that tube got a little bit bigger to accommodate the wire going in there. Now at this point, that's one way. That's kind of the manual steps that you could go through for laying out the wiring. Another method would be to have it auto wire. And so that's your automatic route there. I can say all unrouted wire, and it just goes through and grabs it all then, and it does it based on the tube that's in place here. Let me get our view rotated around, and so you can see now it has routed some of the wire just based on the closest location to the end of the tube to the connecting points that it wants to go through. Now, if you look at it and go, you know what, I really don't like the way this one maybe ended up because of it registered as closer to this one versus this one, you can go in there and select a route and say unroute it, and we'll say okay to that and let it unroute it again, and then we can go through the process once again, unrouting and then routing it ourselves manually. So again, I'll say select that route, my first segment being this tube instead to this tube, and we'll say okay. And there at that point now we've got it all routed, say finish cable and harness, and we're good to go. So now at this point we've utilized both the Autocad as well as a couple of different flavors of Autocad, as well as Inventor tied all together into our 3D world. We've done some automatic meshing, okay, some simulation, and some automatic layout, so that again we can. Oh, let me restart this. Now, what this little video I'm showing now is just kind of an overview of the things that we've talked about as far as the digital prototyping and the workflows that go through the different products within the suites. We did look at showcase a little bit to get nice rendered images of our components, of course the document layout and how it keeps up with us in the model. As we make changes in the model, it changes it. We pulled in AutoCAD, we did some motions, and then utilized AutoCAD Electrical as well as AutoCAD Mechanical for legacy data to tie it right into our Inventor and get our 3D model in shape for fabrication and development. So at this point, I'd like to open it up. If there are any questions, feel free to, I believe you just type it in, and at this point, Marcia, you'd like to take over?
Thank you, Dennis, for an excellent presentation. Feel free to type in your answers or questions, excuse me. And we do have one coming in. It's wondering how applied software can help your firm. For those of you on the webinar, you're not as familiar with applied software. We are the world's oldest software reseller for Autodesk. We are one of 6 platinum resellers in the United States. Platinum designation by Autodesk is earned and retained on a quarterly basis, and they actually survey our clients after the sale, and all of you know that's when really the rubber meets the road. And so by obtaining a certain level of response and quality responses, we are able to get the platinum designation. So due to our excellent staff and technical expertise is one of the reasons, and as you can see, Dennis is a major part of our support staff as well as training. So in order to further how we can help you, please call me. My direct number is 404-564-1870, and I can definitely coordinate an appointment with our appropriate outside sales rep for your territory. So a few other things I'd like to share with you before you depart. If you have not already gone to the internet, please search Live Lab Learning on Facebook and like our page. That way you will always be receiving the latest information and special training offers. If you visit livelablearning.com, there is a complete schedule of upcoming training and future informational webinars, such as tidbits and software updates. There will be a recording of today's session, and you can look for an email from us soon with the link for your reference, and please feel free to share it with any of your colleagues. And let me just check to see if we have had any additional questions. And with that, we appreciate and thank you for joining us today, and we hope you find this webinar informative and helpful to your design and engineering practice.